I'm Naomi Durand. And
Hi, I'm Taiki Tashiro.
And this is the Pinball Wizard.
We started by purchasing DXF files online. Once we purchased those, we got everything laser cut in Bray. And then we assembled. There are some 3D printed obstacles and obviously a bunch of sensors in place. We had to drill holes to feed all the wires underneath. And then on the underside, we have a breadboard and an Arduino.
As you play the game and as the ball bounces around, it will play a song, and hitting various sensors. We mainly used piezo's and IR sensors. Also a couple switches and through beam sensors, but mostly piezo's and IRs, and those change some parameters. Like we have a percussion track that comes on and off. It goes a semitone up when it hits some sensors.
First is piezo, like these 3 piezos, and then there's a launcher piezo, and then there's 3 more piezos behind you cannot see, and then there's an IR sensor each ramp, like here, and here for going up to the second layer. And what else? Oh, there is a display for showing the timer and score, and then finally there are 2 switches. When you flip it, you can change the musical parameter like this. Another feature is when the marble goes through this piezo, it starts the timer, and then music starts, and then when the IL beam senses the pinball, that's the end of the pinball game. And then for the display, there's timer, and then piezo here, and then IL beam sensor is the end for the ending. So when I start the timer, I can start the ball.
All of the Arduino sensors send data straight to Max, and we have it set up such that there's a melody playing, kind of bouncing around between the notes in one chord, randomly selecting them. And there's also a randomly selected rhythm. So there are 3 preset measures, and it just picks one of those measures randomly and then does the rhythm for that. Mm-hmm. How the sensors correspond is that these 3 piezos here, each of them correspond to a different percussion section. So we have a bass drum, we have a clap, and we have a cymbal, I believe. And those each have different rhythms, and they're triggered by the ball bouncing off. We also have a different setting where when it's on a higher level or a lower level, it'll go either 2 octaves up or 2 octaves down. And we detect that by having IR sensors at the entrance and exit of all of the on and off ramps. And we also have kind of a baseline chord underneath that lays down all of the notes in the major chord that's played. And we have a little bit of a pitch bend sequence whenever the game starts, whenever the game stops, and that a few obstacles are out. When it starts, it hits this sensor going up, and it plays a random melody.
Come back to this thing up.
And we also have a pitch bend effect that goes off at the beginning of the game at any pitch transitions. It's just kind of a transitioning effect, about like 750 milliseconds of pitch bend to help out the transitions a little bit. So we have momentary switches for the flippers. They're automatically pressed down when the flipper is kind of in its natural spot, and then when you bring it up, there's a guitar strum. We also have piezos at the bottom of all of these holes and drop-throughs, and the other ones underneath here as well, to measure when it drops down and when it goes to the bottom level. So we have a cymbal crash when it goes down, as well as going down a few octaves. And I guess just musically over time, it accelerates. The notes of the melody go to a wider range. It sort of becomes, even though there is a threshold to how fast it speeds up, when you have the bass drum going, it becomes very, very chaotic at the end. The pattern was designed to be CNC, but since it was a little larger than the bed of the X-Carve, we had to laser cut it instead, but laser cutting meant that there was, a little bit of distance on the edges that encroached inward everywhere. So theoretically it was supposed to press fit, but it is a little wobbly and doesn't quite press fit, which ended up being nice for us in a lot of ways because we had to take it apart and put it back together so many times to get all the sensors in and to tweak at things inside. So it was useful in the end, but it meant that kind of finalizing things was a little tricky.
Mm-hmm. So there are Arduino Mega over there, and then a breadboard here.
Wow.
Yeah, most of them are extended with additional wires. Those. And then importantly, for the IO beam sensor, we broke the Arduino Mega due to overcurrent.
Right.
So we have additional, what is that? This code. This guy is for supplying 5 volts.
Yeah, there's a barrel jack back there.
Mhm.
It's hard to see. These beam sensors here pull something like 30 milliamps when they're running. And so having 3 of those going totally roasted the first Arduino.
The piezos, we couldn't use just a threshold with the piezos because sometimes they would take a really long time to come back. So we couldn't use a regular threshold, so we had to always be comparing the maximum and minimum of a given section to see if there was a significant jump. So that's what this function is for. So we apply that anytime we use a piezo. There's a subpatch for accelerating the tempo. There's a subpatch for the rhythm here, and what this does is it creates 3 different rhythm measures. For example, this measure would just be like bum 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 da dum bum bum da dum, and then this one would be da 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 da, and this one is da 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 da. All right. In Reason, we only have 4 different channels going. We have this and a 19 for the melody. We have this Maelstrom synthesizer for the bassline chord underneath. And the main thing that we changed in there was the pitch. The pitch of the first modulator. That was what kind of gave the pitch bend effect at the beginning at any of the transitions. We have the Kong for the percussion, and then this less and a 19 is the guitar for the strums on the toggles when you hit the flippers. Yeah. Something else about the ball, we ended up finding that, so at first, they were marbles, so it was glass. Even though it was slightly pigmented, it was not setting off the original IR sensors. So to try to curb that, first we spray painted it black, and that was not detected either, which probably could have run some testing before painting it, but then Joe had the great idea of putting copper tape on it, and that was so reflective that it processed really well.